everyone. So this is a video for worksheet 7.7. So this is kind of a standalone worksheet. There's no homework to this particular worksheet, and that's just because I wanted to expose you to the idea of identities. You will see this in your calc class. I'm also going to give you a reference sheet of all the different identities, but I just wanted to at least introduce you to the identities. If you took a full-length semester trig course, you would spend several weeks on identities, but I just want to expose you here to that idea. So to start with, we've got this triangle, and we're going to use the Pythagorean theorem to determine the relationship between x, y, and r. And so that relationship is going to be x squared plus y squared equals r squared. And then part B, it says determine a formula for relating cosine, theta, and x. So remember that our cosine of theta is equal to x divided by r. We typically saw it a lot as r cosine theta is equal to x for that horizontal distance. If we wanted to connect it back to the triangles, right, so if this is our angle, the cosine would be the adjacent over the hypotenuse. So we still get that same idea, x divided by r. Okay, we're going to do the same thing with our sine function. So sine is opposite over the hypotenuse. So sine of theta equals y divided by r. We also saw it a lot with our circles where we had r sine of theta is equal to y. Okay, so now what we want to do is take those two ideas from parts B and C and connect it back to our Pythagorean theorem. So our Pythagorean theorem from part A we said was x squared plus y squared equals r squared. And then from part B, notice here we said x was equal to r cosine theta, so we're going to repeat that. So x is equal to r cosine theta. So I'm just substituting that in. Plus, and then our y we said was equal to r sine of theta, so I can substitute that in for y, so we get r sine of theta, quantity squared, is equal to r squared. Okay, well typically when we work with trig, we always want to think about working with a unit circle. And we saw back in a previous worksheet that when we're using the unit circle, we let the radius be equal to 1. So what we're going to do is substitute all of those r values with 1. So that leaves us with cosine of theta, quantity squared, plus sine of theta, quantity squared. And again, the r is 1, 1 squared is 1. And this right here is what we call our Pythagorean identity. Typically, we don't like to see all of those parentheses, so what mathematicians have done is just moved that square instead of outside the parenthesis to be cosine, and then technically the squared there, theta. And that's just for simplicity, without having to have all of those parentheses. So this right here is called the Pythagorean identity. So cosine squared theta plus sine squared theta is equal to 1. And really this came from our generic Pythagorean theorem of x squared plus y squared equals r squared, and then just substituting in what we know the horizontal and vertical distances represent. Okay, so like I said, if you took a full semester long trig class, you would spend weeks on the identities. This right here is just one of the identities. If we look at the next sheet, you can see there are lots of them. So the one that I just showed you was just one of the Pythagorean identities. So we've got sine squared theta plus cosine squared theta is equal to 1. But you can see that there are a couple other identities. We're not going to dive into those, but just know that they exist. Same thing with other types of identities. We have double angle identities, we have cofunction identities, half angle identities. So these are all things that would come up in a full-blown trig course. So this particular workshop that you are taking is really just to give you an introduction into the trig, but there's so much more beyond this course. You'll also recognize on this sheet some of the things we've already talked about. So we've got this right triangle definition. So we talked about the sine, cosine, and tangent, but know that other things exist. We've got these reciprocals of this is called, so it's listed as CSC, we call that cosecant. SEC is secant. Here, COT is cotangent. They are just the reciprocals of the sine, cosine, and tangent functions. This next part, the circular functions, we spent a lot of time with that. You will recognize, again, the sine, the cosine, and the tangent, and then their reciprocals are listed right next to them. And then we did spend some time on the unit circle, which is the circle you see here on the right. We didn't dive into the points that exist on the circle, but know that there are common angles that are well known. So here we have 30 degrees. That is the same as pi over 6 radians. And then they have x and y values, right? So we explored all of those ideas of looking at degrees and radians and looking at the vertical and horizontal distance. But because the 30, 45, and 60 degrees show up so often, there's this nice unit circle with the solutions already shown on there. So if somebody says, what is the vertical distance of 30 degrees, we know it to be 1/2. If somebody's asking what is the horizontal distance, that is the square root of 3 over 2. Okay, so this reference sheet is just nice to have, so that way you've always got some information at your fingertips.